Alrighty, so let's have a look at some applications of trigonometry in two dimensions. So this will be a two-parter. We're going to look at two dimensions and we're also going to look at three dimensions as well. Now, in the first video, we're going to just look at the two dimensions and then there'll be a follow-up video that will focus mainly on the third dimension. So let's jump in and have a look. So, one thing we need to talk about first before we jump into the applications is we need to talk about the relative angles in relation to a problem. So let's say we had a building, and let's draw a pretty crappy looking building. And this crappy looking building, okay, here it is. Here's my building. Now, depending on where you are in relation to this building and how you're looking, will determine what type of angle you will make to either the bottom or the top. So say, for example, that, this is a big skyscraper and you're down here. Hey, look, there's you, that really small person. Here you are, okay? And you're pretty much horizontal to the ground. Then the angle, okay, from the bottom to the top up here. Okay, we call this the angle of elevation. So this here is the angle of elevation. Now, the other type of angle we can have, so the angle of elevation, of course, being measured from the horizontal, the flat ground, and you measure it going up. Now, the other angle we can have, okay, is if we pretend that there was a horizontal line coming across here from the top, or in fact, we'll draw it coming across from the top of the roof of this building, okay, then the angle of depression is measuring down from that horizontal down here. So this is the angle of depression. So if you see words like angle of elevation or angle of depression, that's how they're being measured. So if it said, this building had an angle of depression of like 20 degrees, then what it's saying is that this angle in here would be 20 degrees, okay? So using some trigonometry, you might have this value here and this value here. And if it tells you that it's 20 degrees on the inside here, then you would have to use your intuition to work out that this angle in here is going to be 70 degrees, okay? So just a little side note that. Excuse me. Okay, let's have a look at, we'll just do one example of this, I think. And we'll do the classic, the difference of two buildings. So let's say we have two buildings, okay? And here's Google's building. Let's make it MySpace. No, you guys probably actually don't know what MySpace is. Let's make it Facebook. Okay, here's Facebook's building. Okay, and then let's say, and it's 158 meters tall. Okay. And then 50 centimeters, sorry, 50 centimeters, 57 meters away, 7 meters away, a new company called, this new upcoming indie company called Snapchat moves in, and they build a building that's even bigger, that is 237 meters, okay? Now, let's say that we wanted to connect a, let's say that just in case, these two companies have come up with a deal, okay? So Facebook and, what did I say, Snapchat have come up with a deal, and I don't know how to really draw a ghost. Oh, that's actually so bad. And in case one of their internet goes down, they want to hook up, like they want some backup, and the way they're going to do this backup is they're going to connect a wire, okay? And the way they're going to connect the wire is they're going to connect the wire between the buildings like this, okay? Now the question is, well, how long? Okay, or sorry, at what angle does the wire need to hang out? Okay, what angle does this wire need to hang out? So Snapchat and Facebook want to share a cable between the two buildings, the roofs of the two buildings, mind you, and they want to know, okay, what angle do they need to fire the wire from the Facebook building to the Snapchat building. So how would we work that out? Well, I hope you guys have noticed, but on the inside here, we can actually draw up a small little right angle triangle. Okay. And we're actually going to use this right angle triangle in here to work out this angle. Now we're going to be looking for an angle of elevation this time because we're firing up to the second building. Okay, so we're looking at this angle in here, this angle of elevation. If I was shooting down, and I was given an angle of depression, or was asked to find an angle of depression, then I'd have to do something else. But in this case, we're looking for the angle of elevation to fire up to between the building. So let's just take this triangle and we'll put it out here to make it a bit easier to work. Okay? And I would recommend doing this. So after you've drawn your little diagram of the situation at hand, okay, actually bring the information, the important information out and deal with it on the outside, okay? Now it's a trig problem, so I'm going to write SOHCAHTOA on the side here, and we need some other information about this triangle. We need to know some lengths so we can do some trig, okay? Because we're trying to find what this angle is. So we know what the base of this triangle is because this base of this triangle is just the difference between these two buildings, which is 57 meters. So we know that length down there, so if I zoom in a little bit, is 57 meters. Now, can we work out the height? So we can work out what this height is here, so how tall it is from here to here, because it's just the difference in the building sizes, okay? So Facebook's building is 158 and Snapchat's 237. So that length here of this triangle is just the difference in the two. If I do 237 and I minus 158, which is just this total distance here, so this whole distance along here, minus the distance of, or the height of this building on this side, it's going to give me that leftover bit in the middle, okay? So that difference in between the two buildings. So doing this, we get 79 meters, and we can put this into our diagram like this. Excuse me. So once we've got this 79 meter height, and we've got our 57 meter length, we can go in and now solve this like a trigonometry problem. Okay, so looking at my angle that I've been given, I've got an opposite and I've got an adjacent. So I'm going to be using the tan ratio. It's going to be tan theta is equal to opposite on adjacent. Okay, let's substitute in the things I know. So I don't know what theta is, so I'm just going to leave it at that. My opposite value is 79. My adjacent value is 57. Now remember, when we go to solve this problem, we need to get the angle, the unknown angle by itself. To do that, we use this inverse tan notation. Okay, we must use this inverse tan notation. And once we've done that, okay, we just pop it into our calculator. So if I go over here and have a look, I do shift and tans to get that -1 because that's how we moved it across the other side. We did that -1 one. I'm going to put 79 over 57, and hopefully this works. Hopefully I'm in degrees, I am, and we get an angle of 54 degrees, and we'll go to the nearest minute, 11 minutes. Now, if your answer becomes a decimal like this button over here, so where my mouse is, the degrees, minutes, seconds button, if you just hit that, it'll actually change it automatically for you. Okay, and that does it for us like that. So that was an application in 2 dimensions. The next video will be an application of 3 dimensions.